Hello learners, my dear students, we are going to see about halogen lamp control today. Okay, in vehicle applications, we are using different types of lamps such as halogen lamps, HID lamps and LED lamps, etc. So now today we are going to see about how halogen lamps can be used and controlled for automotive applications. Okay, so the given circuit is a 12 volt halogen lamp control circuit designed to drive one or more halogen lamps safely while providing soft start protection. See, here is the soft start capacitor. This provides soft start protection. And this is the power supply circuit. This is the power supply circuit. This is the filter circuit, and this is the MOSFET, and this is the lamp, halogen lamp. As far as we have considered, this is fuse for circuit protection, and this is regulator circuit. This is regulator IC, 3-pin regulator IC, and this is the stable multi-vibrator triple for IC timer. This provides oscillatory circuit structure, and this is the monostable multi-vibrator circuits. Okay, so let us see how this circuit works and how its brightness and parameters are getting controlled using this circuit. Okay, halogen lamps have a very low resistance when cold, causing a large inrush current at switch on. Okay, this high starting current reduces lamp life by stressing the filament. This circuit overcomes the problem by gradually increasing the lamp current during startup. So the circuit mainly consists of the following sections. One is power supply section, as already said, which consists of transformer, which is a step down transformer, and this is the bridge circuit. Okay, so the power supply section converts the AC mains into a regulated DC supply. So the component involves halogen transformer, bridge rectifier, capacitors. These are all filter capacitors, and fuse. This is the fuse. The input is 24 volt AC for step down transformer, and which is stepped down to 12 volt AC by transformer T1. Then it is given to the bridge rectifier, which converts the voltage into required voltage up to 24 volts. Sorry, this transformer is 24 volt. Sorry for I mentioned as 12 volts. This is 24 volt. So it converts 24 volt output DC. Then there are two capacitors here. These capacitors are used for improving the DC quality. So these capacitors filters the high frequency noise and improves the DC quality from the bridge rectifier. So the fuse which indicated here, 10 amps fuse, protects the entire circuit against overload and short circuit conditions. The resulting DC voltage is approximately 24 volt, which is used for powering the halogen lamp and the control circuit. So the next one is voltage regulation session. This is the voltage regulation session. So this 7-8 means that this is a positive voltage regulator, and 1-5 means that output voltage is 15 volt. Although the lamp requires 24 volt, the electronic control circuit needs a stable lower voltage. So that voltage is provided by this voltage regulator circuit. So here this next one is the oscillatory circuit, this one. So it consists of a 555 IC timer and diodes. This is D2 and this one is D3, two diodes here, and other resistances here. So actually it continuously, this 555 IC continuously generates square wave pulses at approximately around 22 kilohertz. Okay, so the frequency may be varied by adjusting the resistance and capacitance value of the 555 IC timer. So the resistor, capacitor and diodes, this determines the charging time, discharging time, and the frequency of the square wave pulses that is produced by this oscillatory circuit. Okay, so next one is the monostable multi-vibrator circuit. Here also 555 IC timer, another 555 IC timer is used. This VR1 is the variable resistor 1 and variable resistor 2. The IC2 operates as a monostable multi-vibrator. Each trigger pulses from the IC1, that is from the IC 555 IC1 generates one output pulse. Okay, so the pulse width is adjustable. This pulse width is adjustable by adjusting this VR1 and VR2. So the VR1 is meant for brightness adjustment, and brightness means minimum brightness adjustment, and this one is for maximum dimming adjustment. So changing these resistance values changes the on time of the MOSFET. How? See, the output of the 555 IC timer is given to the gate of this MOSFET. So how the MOSFET transistor works? Whenever the gate supply is given to the MOSFET, it gets turned on. Whenever there is no gate pulse, it is in turned off condition. So we can see from the circuitry that whenever the MOSFET is turned on, only then the lamp will glow. Otherwise, the lamp will not glow, because this creates open circuit here due to the off condition of MOSFET. So whenever the gate pulse receives the high signal, then lamp will start to glow. So for longer pulse width, lamp receives more power, provides higher brightness. For shorter pulse width, so less power will be received by the lamp and provides very lower brightness. Okay, so the next important one is soft start circuit. So in soft start circuit, this is the soft start circuit, which consists of a capacitor called soft start capacitor. When power is first applied, the capacitor is discharged. Then after some time, it charges slowly through the circuit. So consequently, the PWM duty cycle increases gradually. Therefore, lamp voltage increases slowly and lamp current increases gradually. So filaments heats up smoothly. So this greatly reduces the inrush current that normally occurs during switching. So the importance of soft start is to provide low inrush current and to smooth the heating of element, and makes the lamp with the longer, makes the lamp to run with longer life and better reliability, to reduce the electrical stress on transformer and MOSFET. So usually this without soft start, it will high starting current will be occurred from the supply side. So filament gets stressed. Filament means our halogen lamp filament, I am telling. So frequent lamp failure will be happened due to this high starting current and stress of the filament. So this will result in the reduced life of the lamp. So in case of protection, so to save this, we have to give some protective components, right? So that's why we are putting here D1, D2 and D1, D2 and D3, then again this fuse, etc. Because D1, which protects D1 is provided, we can see D1 is provided for freewheeling. This is a freewheeling diode, reverse biased diode, which is which protects the reverse voltage and voltage spikes. And D2 here, D2, and this is D3. So these fast switching diodes control the charging and discharging path of the timing capacitors, helping maintain accurate PWM timing. So this fuse disconnects the supply during excessive current or short circuit, protecting the transformer, MOSFET and lamp. So this is how the circuit is working, and the lamp is controlled through the MOSFET driver. Instead of MOSFET, we can use some other switching devices also, such as IGBT, SCR and all. But nowadays, due to its effective implementation and get perfect switching, MOSFET is usually preferable for this kind of control circuit applications. MOSFET is full form for MOSFET is metal oxide semiconductor field effect transistor. It is one of control device mainly used in power electronic circuits to handle high power applications in the control circuit, in the power circuitry. Okay, so advantages in the sense we can say um, it provides soft start protection for halogen lamps, reduces filament inrush current, and extends lamp lifespan. High efficiency due to MOSFET switching. Okay, that's what I have said already. And adjustable brightness using PWM and stable operation with regulated power supply. Provides very low heat generation when compared to the linear control, and gives simple and economical design using 555 timer ICs. Okay, so applications in the sense stage and audio lightings, decorative lightings, but our focus is on automotive applications. It is widely used for automotive applications. So we will move on to the next lamp. This is called HID lamp. So this is HID lamp. It is a gas discharge lamp that produces light by creating an electric arc between two tungsten electrodes enclosed inside a quartz arc tube. This is the arc tube you can see. So with in this from this arc tube, two tungsten electrodes are connected, and between these electrodes the arc will be created. Okay. So this enclosed in a quartz arc tube, right? Right. The arc tube contains a small quantity of mercury and metal halide salts. Unlike incandescent or halogen lamps, an HID lamp does not have a filament. So you can see there is no specific filament, but here we are using the mercury and metal halide salts to create arc. So an HID lamp does not have a filament, and instead it generates light from the ionization of gases and metal vapors, resulting in a much brighter and more energy efficient light source. So in the view of construction, we can see a quartz envelope. It is an outer protective bulb made of quartz or hard glass. It withstands high temperatures and protects the inner components from the environment. Arc tube, then next one is arc tube. It's a small quartz tube located inside the lamp that contains mercury vapor and metal halide compounds. This is the region where light is generated. Okay, right. Then electrodes, two tungsten electrodes are placed at opposite ends of the arc tube. They provide the electrical path for arc formation. So ions get traveled from the one electrode to another electrode, so that it can ionize the ions here between the space here. Metal halide atoms and mercury ions are there. It will ionize and produces illumination. Here only the light is getting generated. So mercury and metal halide atoms are chemicals vaporized during operation and emit intense visible light when excited by the electric arc. So the working principle behind this HID lamp is when switched on, the ballast or electronic controller supplies a high voltage ignition pulse, typically between 2 kilovolt and 25 kilovolt, to initiate an electric arc between the electrodes. Initially the mercury vapor is cold, so the lamp emits a dim bluish light. As the arc heats the arc tube, the mercury and metal halide salts evaporate and become ionized. The ionized gases increase the pressure and temperature inside the arc tube, producing an intense white light with excellent brightness and color quality. So during the operation, the ballast regulates the current because the electrical resistance of the arc decreases as temperature increases. Without a ballast, excessive current would flow and damage the lamp. So this is how the lamp operates. Applications mainly used for automotive headlights. Xenon HID lamps is an example for HID lamps on street and highway lightings, etc. So as a conclusion, HID lamp generates light through an electric arc inside a quartz arc tube containing mercury and metal halide vapors. Okay, so let us see how the operating characteristics are varied while it's working. So this graph illustrates the operating characteristics of HID, high intensity discharge lamp. HID means high intensity discharge lamp. From the instant it is switched on, until it reaches steady state operation. It shows how the lamp voltage, lamp current and lamp power change with time. So the first stage is ignition stage. At the instant the lamp is switched on, the ballast generates a very high ignition voltage to strike an electric arc between the electrodes. At this stage the lamp voltage is very high, while the lamp current is nearly zero because the arc has not yet been established. The second one is current limitation stage. Before that, one point to be noted is the high voltage generated is it's a pulse ionizes the gas inside the arc tube and initiates conduction. Okay. Second one is the current limitation stage. Once the arc established, the ballast immediately reduces the voltage and limits the current to protect the lamp. So the lamp current rises rapidly to a controlled value, while the lamp voltage remains relatively low because the gases inside the lamp are still cold. During this period, the lamp power begins to increase gradually. So you can see by this, the color is different for each characteristic. This is the voltage curve, this is the power curve, and this one is the current curve. Okay, so by this you can see at which stage which parameter gets varied and how it gets varied. Okay, so and the next warm up stage, as the lamp continues operating, the mercury and metal halide salts inside the arc tube vaporize due to the heat generated by the arc. Okay, the pressure inside the arc tube increases, causing the lamp voltage to increase gradually. So then if you see the power of it's a multiplication of voltage and current value of the lamp. So during this warm up period, the light output also increases until the lamp reaches full brightness. Okay, then running stage. After the warm up period, the lamp reaches its normal operating condition. The lamp voltage stabilizes at its rated value. The lamp current settles at a lower steady value, and the lamp power remains constant. The lamp now produces maximum light output with stable color and brightness. The electronic ballast continuously regulates the current and voltage to ensure efficient and reliable operation. Okay, I hope you have understand about the characteristics of halogen, HID lamp. Also, you can aware about how to control the halogen lamp. In the next video, we will see how to control the HID lamp also. Thank you for your patience and listening. Thank you.